Hi, I'm following along with Paul McWhorter's Raspberry Pi lessons. We're on number 21 and we're using the Echo sensor, the HC-SR04 ultrasonic sensor. And Paul showed us how to use it, and it doesn't even use a library. So I got to admit, I come from the Arduino side, and when I've tested this or used, haven't ever used one in a project, I don't think, but I always test them and show them to my students when I'm teaching Arduino, and always used a library. And I thought I knew what was going on behind the scenes, but Paul's explanation showed that didn't have it quite right. I had most of it right, but I was really happy to see the code behind what the library does, the behind the scenes code there. So I really appreciate Paul for showing us that. Today was basically typing out again what Paul had. But then for homework, he asked us to, he gave the travel time and he wanted to convert that to distance based on the speed of sound. So I was online and I found speed of sounds everywhere from 761 miles per hour to 767 miles per hour. So I knew Paul wanted to just do the math on it. So I decided, I looked and I found a online equation platform that I could just type in the equation the way it looks. So there's what I came up with. So when we're doing the conversion, Paul showed us this before, that you change the units from your miles to feet, and then the inches, and then your time from hours to minutes to seconds. And once you do that, each one of these equals 1, so you're multiplying it by 1, so it really doesn't change. But your units, top and bottom, cancel, miles cancel, feet cancel, leaving you inches, then hours cancel and minutes cancel, leaving you seconds. So you're going to end up with your answer in inches per second. So you just multiply through these things. You don't have to worry about multiplying by 1. So here's this. And then you same way on the bottom, you got 60 times 60. You end up with this, and you end up with about 13,500 inches per second. So that's what I used in my equation. So like I said, basically it was Paul's code that he showed us, but just a added calculation for distance. Of course, I don't know, I don't think Paul mentioned it, but the sound has to go out and then come back. So you got to divide your distance that you come up with by 2 to get the one-way distance, because you're doing round trip on this. Anyhow, let's see if I can grab the code. And like I said, this is Paul's code with shorter variable names. I don't like long variable names. I don't like typing. So I got start time, end time, and total time, or total time, or travel time, I guess you could call that. So, and then we got distance. So what you do is you take your distance, which is going to be a fraction of a second, and then you're going to multiply it by the 13,500, and then you're going to divide it by 2. So that's how that works. And I just rounded it to 2 decimal places so that have 2 decimal places, hundredths of an inch, I guess. So, and then just printing them out. And that's all we're doing with it. So it was short and sweet. Let me move myself out of the way here a little bit and run this code. And you can see I got my hand just about 8 inches from it. I don't have a ruler on me, but this is about 1.5 inches. So that's right. This is about 6 inches, 7, 6, there we go. And I got this thing pointing to the wall, but if I move my hand out of the way, it should be going to the wall. And you can see every once in a while I'll get that 73, 74 inches. I measured it with a tape measure, and that's what I got to the wall. And so if I back out, get out of the way a little bit, it gets a consistent range. So I would say my range is at least 74 inches total and down to maybe 1.5. If you get much closer than 1.5, there, I don't think it's accurate. I'm almost on top of it. Yeah, maybe down to 1 inch, but I wouldn't say that's accurate. But that 74 inches to the wall is pretty accurate. So close enough for government work. So short and sweet this week. And just thank Paul for the lesson. I learned a lot from him this week. I always learn something, but today I learned a lot from him. So I want to thank him for all he does and look forward to more lessons in the future. Thanks for watching.